October 15, 1941. Ural Tank Factory Number 183, Nizhny Tagil, Soviet Union. Temperature inside the cavernous production hall hovered near freezing despite the heat from hundreds of welding torches and forge operations. Industrial facility hastily constructed in the Ural Mountains 1,400 kilometers east of Moscow, where Soviet leadership had ordered evacuation of critical war industries to protect them from the German Wehrmacht forces that had advanced to within artillery range of the capital city. Alexei Dmitrievich Morozov, 42-year-old master welder who had spent 20 years working in Kharkov's locomotive repair yards before the war, stood beside a partially assembled T-34 medium tank hull, examining the turret ring mounting area where thick armor plates required precision welding to create the rotating foundation that would support the tank's main armament. The official production schedule called for each T-34 hull to spend 14 hours in the welding section, where teams of skilled welders would methodically join the armor plates using electric arc welding techniques that Soviet tank design bureaus had specified as necessary to achieve structural integrity sufficient for combat operations. This careful, time-consuming process was killing Soviet soldiers on the front lines not through technical inadequacy but through sheer mathematical impossibility. German forces were destroying Soviet tanks faster than Soviet factories could produce replacements, and the production bottleneck wasn't steel availability, factory capacity, or workforce size, but rather the fundamental limitation that proper welding of thick armor plate simply required time that the Soviet Union didn't have. The desperate strategic situation facing the Soviet Union in autumn 1941 made production speed a matter of national survival rather than industrial efficiency optimization. German Army Group Center had captured Smolensk, was besieging Leningrad, and had launched Operation Typhoon intending to capture Moscow before winter set in. Advances that had destroyed thousands of Soviet tanks and left Red Army armored formations critically short of operational vehicles at precisely the moment when mechanized counteroffensives represented the only realistic possibility of stopping the German advance before it reached the Volga River and severed the Soviet Union's north-south communications. Stalin had issued direct orders to Soviet industrial commissariats demanding exponential increases in tank production, instructions that Soviet factory managers and engineers understood were impossible to fulfill using conventional manufacturing methods because the time required to properly weld thick armor plates created an insurmountable bottleneck that no amount of additional workers, longer shifts, or priority resource allocation could overcome. The mathematics were brutally simple. Each T-34 required approximately 400 linear meters of structural welds joining armor plates ranging from 20 mm to 45 mm thickness, welds that needed to be executed by skilled workers using techniques that ensured full penetration and proper fusion to prevent catastrophic structural failures in combat. At standard welding speeds for thick armor plate, completing these welds required approximately 140 man-hours distributed across multiple skilled welders working in sequence. Time constraint that limited factory number 183 to producing approximately one completed tank per 20-day production cycle when accounting for all manufacturing steps from raw steel to completed vehicle ready for delivery to military units. Morozov's background as a civilian industrial welder gave him perspective that Soviet tank design engineers lacked despite their advanced technical education and theoretical knowledge of metallurgy and structural mechanics. He had spent 2 decades welding heavy industrial equipment including locomotive frames, pressure vessels, and structural steel for bridges and buildings, work that required understanding not just how to create technically perfect welds, but how to create welds that were good enough for their intended purpose while minimizing time and resources invested in each joint. This practical industrial experience made him acutely aware that Soviet tank designers, trained in academic institutions emphasizing theoretical optimization and best practices derived from peacetime quality standards, had specified welding procedures appropriate for creating the strongest possible joints but wildly inappropriate for wartime mass production, where the choice wasn't between perfect welds and adequate welds, but rather between adequate welds produced quickly and perfect welds produced so slowly that tanks never reached the front lines in sufficient numbers to matter. The official welding specifications for T-34 production called for multi-pass welding techniques where welders would make multiple passes along each joint, building up weld material in layers to ensure complete penetration and proper fusion throughout the thickness of the armor plates. Procedure that produced excellent results in laboratory conditions and was entirely correct from metallurgical perspective, but consumed enormous amounts of time because each pass required cooling between applications to prevent distortion and ensure proper crystalline structure in the weld metal. The specific technical problem that Morozov recognized was that Soviet welding doctrine treated all joints as equally critical and specified identical welding procedures regardless of whether a particular joint would experience high stress in combat or was merely holding armor plates in relative position. This approach was professionally correct from structural engineering perspective because it ensured maximum strength throughout the tank structure and eliminated any possibility of premature failure due to inadequate welding. But it was strategically catastrophic because it meant that Soviet welders spent equal time and care on joints that absolutely needed to be perfect and joints that could have been executed much more quickly using simpler techniques without meaningfully compromising the tank's combat effectiveness. Morozov understood from his industrial experience that approximately 70% of the welds on AT-34 hull were non-critical structural joints that held armor plates in position but didn't carry significant combat loads. Welds that could be executed using single-pass techniques at 3 to 4 times the speed of the specified multi-pass procedures without creating meaningful risk of structural failure during the vehicle's anticipated combat lifespan. The remaining 30% of welds, primarily around turret ring mounting points, hull bottom structures that supported the suspension, and joints around ammunition storage areas where structural failure could be catastrophic, genuinely required the careful multi-pass techniques that Soviet specifications mandated. But by treating all welds identically, Soviet production procedures wasted enormous amounts of skilled labor and time executing elaborate welding procedures on joints that didn't need that level of care. The impossible innovation that Morozov developed was simultaneously technically simple and institutionally revolutionary. He proposed dividing the tank's welds into 2 categories: critical welds that would receive the specified multi-pass treatment and non-critical welds that would be executed using rapid single-pass techniques that violated every principle of proper welding practice but would allow the same workforce to complete tank hulls in 1/10 the time required by official procedures. The proposal was technically heretical because it abandoned the engineering principle that all structural joints should be executed to maximum possible standards, and it was institutionally dangerous because suggesting that official specifications were wrong could be interpreted as criticism of Soviet technical expertise and central planning. Accusations that in Stalin's Soviet Union could result in arrest and execution for sabotage or counter-revolutionary activity. Factory management initially rejected Morozov's proposal when he presented it through official channels, response that reflected both conservative engineering judgment that considered his approach reckless and political caution that made any deviation from centrally approved specifications potentially dangerous for the individuals who authorized it. But the desperate strategic situation and increasingly urgent demands from Moscow for higher production rates created an environment where factory director Ivan Likachev, himself a pre-revolutionary trained engineer who understood both the technical merits of Morozov's argument and the political risks of implementing unauthorized production modifications, made the calculated decision to allow Morozov to conduct limited trial implementation on a single production line while maintaining official documentation showing that approved procedures were being followed, bureaucratic fiction that would provide political cover if the experiment succeeded and plausible deniability if it failed or if central authorities decided to investigate the factory's methods. The technical details of Morozov's rapid welding technique revealed elegant simplicity that professional engineers initially dismissed as dangerously crude, but which proved entirely adequate for its intended purpose. Traditional multi-pass welding of thick armor plate required welders to make 3 to 5 passes along each joint, building up weld material gradually to ensure complete penetration and proper fusion through the full thickness of the plates being joined. Each pass required the welder to remove slag from the previous pass, allow cooling to prevent excessive heat buildup that could cause distortion, and carefully control welding parameters including current, voltage, electrode angle, and travel speed to achieve optimal results. This process was time-consuming but produced welds of exceptional quality that exceeded minimum structural requirements by substantial margins, over-engineering that made sense in peacetime production but was catastrophically wasteful during wartime when the objective was producing adequate tanks quickly rather than perfect tanks slowly. Morozov's single-pass technique eliminated all but the first weld pass for non-critical joints, using higher current settings and faster travel speeds to achieve adequate penetration in one pass rather than building up weld material gradually over multiple passes. The resulting welds had rougher appearance, contained more microscopic defects, and had lower ultimate strength than multi-pass welds, characteristics that would have made them unacceptable for peacetime production or for critical structural joints, but which were entirely adequate for holding armor plates in position on a tank that would likely be destroyed in combat within weeks or months of reaching the front lines rather than requiring decades of service like peacetime military equipment. The implementation of single-pass welding required not just technical modification of welding procedures but cultural transformation of how Soviet tank factory workers understood their relationship to official specifications and quality standards. Soviet industrial culture in the 1930s had emphasized following specifications exactly as written, approach reinforced through Stakhanovite movement that celebrated workers who exceeded production quotas through superhuman effort and perfect execution of approved procedures rather than through innovation or modification of those procedures. Morozov's technique required welders to deliberately violate specifications they had been taught to follow religiously, psychological shift that was difficult for workers trained in Soviet industrial culture where deviation from specifications could be interpreted as sabotage. The initial trial implementation on a single production line required Morozov to personally train welders in the new technique and convince them that they wouldn't be punished for producing welds that looked crude compared to the smooth, carefully built welds they had been trained to create. Some welders adapted quickly, recognizing that the cruder welds were structurally adequate and that the dramatic reduction in welding time would allow them to complete far more tanks in each shift, contribution to the war effort that outweighed aesthetic concerns about weld appearance. Other welders resisted, uncomfortable with producing work that they considered substandard even when assured that the welds met minimum structural requirements, psychological barrier that reflected professional pride and concern about potential punishment if the technique was later deemed unauthorized sabotage. The first T-34 hull completed using Morozov's mixed welding approach, combining single-pass welds for non-critical joints and multi-pass welds for critical structural areas, was completed in 32 hours compared to the 140 hours required by conventional methods, reduction that represented potential to increase tank production by a factor of 4 using the same workforce, factory space, and material resources. Factory quality control inspectors examining the completed hull found the single-pass welds aesthetically inferior to conventional multi-pass welds, but were unable to identify any structural deficiencies that would compromise the tank's combat effectiveness. Assessment that led to authorization for completing the entire tank and subjecting it to the standard test protocol that all production vehicles underwent before being approved for military delivery. The test protocol included driving the tank over rough terrain to simulate combat conditions, firing the main gun repeatedly to stress the turret ring mounting, and inspecting all welds for cracks or structural failures that would indicate inadequate joint strength. The test tank passed all inspection criteria despite its unconventional welds, validation that led factory director Likachev to authorize expanding the mixed welding approach to the entire production line while simultaneously sending carefully worded reports to Moscow describing improved welding efficiency through optimized technique selection. Without explicitly stating that official specifications were being violated, bureaucratic language that emphasized results rather than methods and provided political cover for what was technically unauthorized modification of centrally approved production procedures. The dramatic acceleration of production that resulted from adopting Morozov's welding technique transformed Factory Number 183 from marginal producer struggling to meet assigned quotas to the Soviet Union's most productive tank facility, change that occurred within weeks of full implementation and which Soviet leadership quickly recognized as critical to survival of the state. By December 1941, Factory Number 183 was completing T-34 tanks at average rate of one vehicle every 4.2 hours, compared to the 20-day production cycle that had been typical just 2 months earlier, increase that represented not incremental improvement but revolutionary transformation of Soviet industrial capability. The factory's monthly production increased from approximately 30 tanks in September 1941 to over 170 tanks in December 1941, output increase that occurred without adding workers, expanding factory space, or receiving additional material allocations. Efficiency gain that resulted purely from Morozov's recognition that not all welds required equal care and that wartime production needed to optimize for speed rather than perfection. The strategic impact was immediate and profound. The additional 140 tanks produced in December alone represented more than 4 additional tank brigades that could be deployed to front lines where Soviet forces desperately needed armored reinforcements to halt German advances and begin preparations for winter counteroffensives that would ultimately save Moscow and prevent German victory in 1941. German intelligence monitoring Soviet tank production through various means including aerial reconnaissance of factory facilities, interrogation of captured Soviet personnel, and analysis of destroyed Soviet tanks captured on battlefields, recognized that Soviet T-34 production had increased dramatically in late 1941, but initially attributed this to evacuation and expansion of production facilities rather than to fundamental changes in manufacturing methods. German tank designers and production engineers examining captured T-34 hulls noted that Soviet welding appeared crude compared to German standards and interpreted this as evidence of Soviet industrial inadequacy and inferior quality control, assessment that reflected German assumptions about proper manufacturing practice but completely missed the strategic insight underlying Morozov's approach. The Germans were producing Panzer III and Panzer IV tanks to higher quality standards with more carefully executed welds and superior finish, Vehicles that were indeed better manufactured according to conventional engineering criteria, but which were produced in far smaller numbers because German production methods emphasized quality over quantity. Strategic choice that was appropriate for Germany's smaller population and industrial base, but which meant that German forces consistently faced Soviet tank units that outnumbered them by factors of 3 to 5 despite German tactical and technical superiority at individual vehicle level. The rapid proliferation of Morozov's welding technique across Soviet tank production facilities demonstrated both the desperate circumstances and the institutional pragmatism that characterized Soviet wartime industry. Factory number 183's dramatic production increase caught the attention of Soviet Industrial Commissar responsible for tank production, who dispatched investigation teams to determine how Likhachev's facility had achieved results that other factories insisted were impossible without additional resources. When investigators discovered that the production increase resulted from unauthorized modification of official welding specifications, the response revealed characteristic Soviet pragmatism about violations that improved results. Rather than punishing factory management for deviation from approved procedures, the commissariat issued new technical bulletin that retroactively authorized Morozov's mixed welding approach while maintaining ambiguous language about optimized welding procedure. Selection based on joint stress analysis that allowed central planners to claim they had intended this innovation all along rather than admitting that official specifications had been inadequate and that unauthorized worker initiative had solved problems that central planning couldn't address. The bulletin was distributed to all Soviet tank production facilities with orders to implement the new procedures immediately, dissemination that effectively made Morozov's technique standard practice across Soviet armored vehicle production by early 1942. The human cost of the rapid production increase was substantial and demonstrated that Morozov's innovation, while strategically brilliant, came with consequences that official histories typically minimized or ignored entirely. The single-pass welding technique required welders to use higher current settings and faster travel speeds than conventional multi-pass welding, working conditions that generated more intense heat, more ultraviolet radiation exposure, and more toxic fumes than the slower, more controlled techniques they had previously used. Welders working 12-hour shifts using the new technique experienced significantly higher rates of arc eye injury, painful but temporary condition caused by excessive ultraviolet exposure, respiratory problems from welding fume inhalation, and burn injuries from the more aggressive welding process. Factory medical records from early 1942 showed welding section injury rates had increased by approximately 40% compared to pre-war baseline. Casualties that were considered acceptable given the strategic importance of increased tank production, but which represented real suffering by workers who were already enduring harsh conditions in barely heated factories working extended shifts with minimal food and rest. Some workers permanently lost vision in one or both eyes from repeated arc exposure, disabilities that in peacetime would have disqualified them from welding work but which during wartime meant reassignment to other factory tasks that didn't require perfect vision, pragmatic but brutal approach that prioritized production over individual worker health and safety. The quality implications of mass-adopting single-pass welding for non-critical joints created long-term consequences that only became apparent through combat experience and field reports from tank units operating T-34s produced using the new methods. The cruder welds occasionally failed under combat stress, particularly when tanks sustained damage from German anti-tank weapons that created shock loads the welds hadn't been designed to withstand. Soviet tank crews reported instances where armor plates separated from hull structure after the vehicle was hit, failures that would have been less likely with the more robust multi-pass welds that pre-war specifications required. However, the frequency of these failures was relatively low compared to the much more common cause of T-34 loss, which was catastrophic damage from German tank guns, anti-tank guns, or mines that destroyed vehicles regardless of weld quality. Soviet military analysis concluded that the slight increase in structural failures due to inferior welding was strategically insignificant compared to the enormous advantage of fielding 4 times as many tanks. Calculation that validated Morozov's fundamental insight that wartime production needed to optimize for quantity over quality because additional tanks on the battlefield provided more military value than marginally more durable construction on fewer vehicles. The psychological and cultural impact of Morozov's innovation extended beyond its immediate tactical results to influence broader Soviet industrial culture and approach to wartime production challenges. The official recognition and dissemination of his unauthorized techniques signaled to Soviet workers that innovation and deviation from official procedures would be tolerated and even celebrated when they produced results, message that encouraged other workers to develop their own improvised solutions to production bottlenecks rather than passively following specifications that were often inadequate for wartime conditions. This cultural shift contributed to thousands of small innovations across Soviet war industry, modifications to manufacturing procedures that individually had modest impact but collectively produced the massive production increases that allowed the Soviet Union to outlast Germany in the industrial war of attrition that ultimately determined the conflict's outcome. Soviet factories producing everything from artillery shells to aircraft increasingly adopted the principle that adequate products delivered quickly were strategically superior to perfect products delivered slowly. Philosophy that contradicted peacetime industrial best practices, but which proved decisive in total war, where the side that could sustain higher production rates longest would ultimately prevail regardless of individual product superiority. The specific technical details of how Morozov's welding technique functioned revealed sophisticated understanding of metallurgy and structural mechanics that belied the crude appearance of the single-pass welds it produced. The technique wasn't simply careless welding or abandonment of quality standards, but rather deliberate optimization that accepted lower safety margins on non-critical joints in exchange for dramatic reduction in production time. Morozov had analyzed the T-34 structure to identify which joints experienced high stress loads in combat and which joints merely held plates in relative position. Engineering analysis that required sophisticated understanding of mechanical load paths through the vehicle structure and which demonstrated that his innovation wasn't simple brute force approach but rather intelligent application of engineering principles to optimize the relationship between production time and combat effectiveness. The critical welds around turret ring mounting, hull bottom structures, and ammunition storage areas continued to receive multi-pass treatment that ensured maximum strength, while non-critical welds on armor plates that didn't carry significant loads received rapid single-pass treatment that provided adequate strength for the vehicle's anticipated combat lifespan at a fraction of the time cost. German response to Soviet production increases demonstrated the strategic inflexibility that often plagued Wehrmacht operations despite German tactical and technical superiority at many levels. German tank designers and production engineers, confronted with evidence that Soviet Union was producing tanks in far greater numbers than Germany despite having evacuated major industrial facilities and losing significant territory, concluded that Soviet production claims must be exaggerated propaganda rather than considering that Soviet production methods might be fundamentally different from German approaches. This assessment led German leadership to continue emphasizing quality over quantity in armored vehicle production, strategic choice that meant Germany never achieved production parity with Soviet tank output despite superior industrial technology and more skilled workforce. By 1943, the Soviet Union was producing over 20,000 T-34 tanks annually while Germany struggled to produce 6,000 Panzer IV tanks in the same period, disparity that reflected both German resource constraints and deliberate German emphasis on superior individual vehicle quality. Choice that left German armored forces consistently outnumbered on Eastern Front despite their tactical advantages. The long-term institutional impact of Morozov's innovation revealed characteristic Soviet patterns regarding recognition of worker contributions and official narrative construction around wartime achievements. Morozov himself was awarded the Order of the Red Banner of Labor in March 1942, decoration that recognized his contribution to increased tank production, but which avoided specific description of his actual innovation to prevent official documentation of unauthorized deviation from central planning specifications. The award citation credited him with exceptional initiative in improving production efficiency, using bureaucratic language that acknowledged results while obscuring methods, diplomatic ambiguity that allowed Soviet propaganda to celebrate worker innovation while maintaining fiction that central planning authorities had designed all-important wartime industrial improvements. Morozov continued working at Factory No. 183 throughout the war, eventually becoming deputy chief of the welding section. Promotion that reflected his practical expertise and institutional value, but which kept him in production roles rather than elevating him to engineering or management positions where his lack of formal technical education would have been conspicuous liability in Soviet industrial hierarchy that valued academic credentials even when practical experience demonstrated superior results. The post-war Soviet industrial establishment struggled with how to incorporate lessons from Morozov's innovation into peacetime production doctrine, tension that reflected broader conflicts between wartime pragmatism and peacetime standards in military manufacturing. Soviet tank design bureaus after 1945 reverted to specifying multi-pass welding for all structural joints on new tank designs, returned to pre-war quality standards that engineering professionals considered appropriate for vehicles that would potentially serve for decades rather than months. But Soviet industrial planning also preserved institutional memory of wartime production innovations through classified technical bulletins that authorized rapid welding techniques for use during future mobilization scenarios, documentation that acknowledged the strategic value of Morozov's approach while maintaining that it represented emergency measures rather than preferred practice. This ambivalence reflected uncomfortable truth that Morozov's innovation had demonstrated, that the elaborate quality standards and engineering best practices that Soviet industrial establishment had developed during peacetime were potentially counterproductive during wartime when the fundamental strategic requirement was producing adequate equipment quickly rather than perfect equipment slowly. The broader strategic lesson that Morozov's welding technique illustrated extended beyond specific technical details to fundamental questions about optimization objectives in wartime industrial production. German armored vehicle production throughout World War II prioritized individual vehicle quality and tactical superiority, approach that produced tanks that were generally superior in armor protection, firepower, and mechanical reliability compared to Soviet equivalents, but which were produced in far smaller numbers because German production methods emphasized craftsmanship and precision over speed and quantity. The Panther and Tiger tanks that Germany introduced in 1943 were technically superior to T-34 in almost every measurable parameter, including armor thickness, gun penetration, optical quality, and mechanical sophistication. But they required far more production time per vehicle and were mechanically complex in ways that reduced operational reliability and increased maintenance burden on German logistics system. Soviet production philosophy, as embodied by Morozov's innovation, accepted that T-34 tanks were inferior to German armor on vehicle-to-vehicle basis but recognized that fielding 5 T-34s for every German Panther represented decisive strategic advantage that tactical quality disparities couldn't overcome. The mathematical reality was brutal and undeniable. If German Panthers could destroy 3 T-34s before being destroyed themselves, they still lost the engagement when facing 5 Soviet tanks, numerical superiority that Soviet production methods achieved through accepting lower individual vehicle quality in exchange for far higher production rates. The human story behind the statistics revealed costs and consequences that official Soviet historical narratives typically minimized or ignored entirely. Alexei Morozov, the welder whose innovation transformed Soviet tank production, died in 1958 at age 59 from complications related to chronic respiratory disease that doctors attributed to years of exposure to welding fumes in poorly ventilated factory conditions, occupational hazard that had been exacerbated by the more aggressive welding techniques his innovation required. His premature death represented common pattern among Soviet industrial workers who had contributed to wartime production through methods that prioritized output over worker safety, human costs that Soviet leadership considered acceptable prices for achieving production levels that enabled military victory. The thousands of welders who implemented Morozov's technique across Soviet tank factories experienced similar elevated rates of occupational disease and injury, collective sacrifice that was essential to Soviet victory but which official histories rarely acknowledged explicitly because doing so would undermine propaganda narratives emphasizing technical sophistication and worker protection in Soviet industrial system. The technical legacy of Morozov's innovation persisted in post-war Soviet military-industrial doctrine through concept of rational sufficiency in equipment design and production, principle that explicitly authorized accepting lower quality standards when higher quality provided minimal tactical advantage relative to production time costs. This concept influenced Soviet military equipment design throughout Cold War, contributing to development of weapon systems that Western observers often dismissed as crude or unsophisticated, but which proved remarkably effective in service because they had been optimized for mass production and field maintenance rather than for maximum theoretical performance. The AK-47 rifle, developed by Mikhail Kalashnikov in immediate post-war years, embodied the same fundamental philosophy as Morozov's welding technique, deliberate acceptance of loose tolerances and crude finish in exchange for extreme reliability and producibility, design approach that proved so successful that the AK-47 became most widely produced military rifle in history despite being technically inferior by many conventional metrics to more sophisticated Western rifles. The parallel between Morozov's tank welding innovation and Kalashnikov's rifle design illustrated that the lessons Soviet military industry learned from wartime experience wasn't about specific technical solutions, but rather about fundamental optimization philosophy prioritizing practical effectiveness over theoretical perfection. Modern historical reassessment of Soviet industrial achievement during World War II increasingly recognizes that Soviet victory resulted not from technical sophistication or central planning efficiency but from pragmatic willingness to accept good-enough solutions implemented at massive scale, approach that Morozov's welding technique exemplified. Recent scholarship analyzing Soviet wartime production emphasizes that Soviet industrial strength came from ability to rapidly adapt production methods to wartime requirements rather than from superior pre-war planning or technical expertise. Revision that challenges both Soviet-era propaganda narratives crediting central planning for industrial success and Cold War-era Western narratives dismissing Soviet industry as inherently inefficient. The reality revealed by detailed examination of cases like Morozov's innovation was that Soviet industrial systems succeeded despite, rather than because of central planning, succeeding specifically when it allowed practical worker expertise to override theoretical specifications produced by designers who often didn't understand actual production constraints or tactical requirements. This pattern of bottom-up innovation overcoming top-down planning inadequacies repeated throughout Soviet wartime industry, from ammunition production to aircraft assembly to logistics operations, collective phenomenon that produced the material superiority that enabled Soviet military victory despite catastrophic losses and strategic disasters that characterized the war's early years. The final assessment of Morozov's contribution must acknowledge both its profound strategic importance and its essentially tragic character. His innovation saved thousands of Soviet lives by providing Red Army armored units with vehicles they desperately needed to halt German advances and eventually drive Wehrmacht back to Berlin, contribution that was absolutely essential to Allied victory in World War II. But his innovation also exemplified brutal calculus that total war imposed on societies: the choice to prioritize immediate production over worker safety, to accept elevated injury and death rates among industrial workers as acceptable cost of producing weapons faster, to value quantity over quality even when that choice meant producing tanks that were less protective of their crews and more likely to fail under combat stress. Alexei Dmitrievich Morozov wasn't a brilliant inventor who discovered revolutionary new technology. He was a practical craftsman who recognized that wartime circumstances required abandoning peacetime standards and accepting consequences that those standards existed to prevent. His innovation worked not because it was technically sophisticated, but because it was strategically appropriate for circumstances where the alternative to crude rapid production wasn't better slower production but rather military defeat and national annihilation. The impossible trick that made T-34 tanks roll out every 4 hours instead of every 20 days wasn't actually impossible at all. It simply required accepting costs that peacetime society would never tolerate but which wartime desperation made unavoidable. That perhaps is the most uncomfortable lesson from examining innovations like Morozov's. Sometimes survival requires choices that violate every principle of how things should be done, and sometimes those morally ambiguous choices represent the difference between victory and catastrophic defeat.